Very good afternoon. Good morning to all the participants and the respected faculties present over here. Thank you, sir, for providing me the opportunity to introduce such a dignified person. Dr. Shambhavi Mishra is an assistant professor at the Department of Civil Engineering, Motilal Nehru, National Institute of Technology, Allahabad. She earned her PhD from the Indian Institute of Technology, Roorkee, in 2018. She has done her master's itself from Roorkee in 2013. She graduated in 2011 from Sri Govindram Sixraya Institute of Technology and Sciences, Indore, in Madhya Pradesh, in civil engineering. After submitting her PhD thesis in 2018, she had joined Jabalpur Engineering College, Madhya Pradesh, as an assistant professor and worked there for about a year and a half. Dr. Shambhavi's research interests include advanced highway materials, intelligent transportation system, advanced traveler information system, incident management system, and also the geographical information system. Dr. Shambhavi has publications in Indian highway issues published by Indian Road Congress and presented her work in national and international conferences. Also, Dr. Shambhavi Mishra is a member of Indian Road Congress IRC. Dr. Shambhavi Mishra is a passionate teacher, dedicated researcher, and believes that teaching and research must go hand in hand. She loves interacting with young minds and spending her time with and energy in making learning through courses of transportation engineering and enjoyable experiences. So, thank you, ma'am. We are glad to have you here. You may proceed for the session.
Thank you for such a great introduction. Thank you so much. So, as he has already introduced me, so I will start with the presentation now. Today, I'm going to discuss the transportation engineering lab through virtual labs. Okay, so I'm sharing my screen now. Okay, so is my screen visible to everyone?
Yes, it is visible.
Okay, thank you. Thank you for confirmation. Okay, so before I begin, a very good morning to all of you who have joined here, to all the students and faculty members of the college. I'm highly privileged to deliver this lecture here. So, yes, today I'm going to discuss about the Transportation Engineering Lab through Virtual Labs platform, which is an initiative of MHRD on this 5 days national workshop or FDP program on practical learning through virtual lab. Okay, so first we'll have a look on the virtual lab platforms, then we will discuss a few tests related to transportation engineering lab. So virtual lab could be accessed from this link, that is www.vlab.co.in, and this is how the home page of the virtual labs looks like. So it has a broad area of virtual labs in which civil engineering is one of them. And in civil engineering, we have different laboratories set up by different IITs. So the transportation engineering lab is developed by NIT Karnataka. So today we are going to discuss this transportation engineering lab. Okay, so now after clicking on the transportation engineering icon on the virtual labs, we get this home screen in which we have introduction to transportation engineering lab. So basically, transportation engineering lab covers all the tests and standardized tests related to the highway materials and pavement. So as we all know that there are two types of pavements which are used in our country, that's rigid pavements and flexible pavements. So all those materials which are used in construction of such pavements, the test related to them in order to judge their suitability for construction of highways is done under transportation engineering labs. So there are several list of experiments. So these are the list of experiments which are available on virtual labs platforms. There are many tests beyond these list also, but these are the major tests which will be used to assess the quality, suitability of materials to be used as highway materials. Okay, so the first three tests are on aggregates, that is the aggregates which are used on highway construction, like brushing value of aggregates, impact test on aggregates, Los Angeles abrasion test, and the other four tests up to seven are the test on bitumen. So bitumen is a byproduct of crude petroleum. We will discuss the introduction to bitumen in our coming slides. So bitumen is basically used in flexible pavement construction in our country. So it is a remarkable material in highway construction industry. So these are the four tests on bitumen. That is ductility test on bitumen, softening point test on bitumen, penetration test on bitumen, and specific gravity test of bitumen. So today I am going to discuss the penetration test on bitumen, which is used for judging the consistency of bitumen. And if time permits, I will also cover the softening point test on bitumen. So the last test in this transportation engineering lab, that is California bearing ratio test, is the test performed for soil. So as we all know that all type of pavements are constructed over the soil subgrade. So testing of soil subgrade is also necessary before laying on the pavement of them. So this CBR test is the test for soil. So most of the tests have been already discussed on aggregates and soil have been already discussed with you. So today I will cover the bitumen part. Okay, so the penetration of bitumen test. So the aim of the experiment is to determine the consistency of bitumen or grade of the bitumen by penetration test. Here, by consistency, we mean the hardness or softness, or we can say the ease with which the material can be handled. So the hardness or softness of bitumen to be used as construction material is measured by this penetration. So penetration test is basically done for assessing the consistency of bitumen. Okay, so let us first have a look on the introduction to bitumen. So bitumen is actually a residue, or you can say byproduct, obtained by refining crude petroleum. So it is obtained from petroleum industries, the petroleum refineries which produce petroleum for different operations like plating, operating, and other machine operating. They also produce bitumen as their byproduct. So there are various types of grades of bitumen produced by these petroleum industries, depending upon the type of the crude oil used and method of distillation or destructive distillation, which is done in deriving the petroleum from the crude oil. So it is a black or dark color solid, or it is a viscous substance which consists chiefly of high molecular weight hydrocarbons derived from destructive distillation of petroleum. Okay, so bituminous materials are extensively used for roadway construction, that is highway construction in our country and also abroad. So primarily because of their excellent binding characteristics and waterproofing properties and relatively low cost. These bitumen materials have excellent binding characteristics. They can keep the aggregates binded together. They have also excellent waterproofing characteristics, which stops the entry of water into the highway pavement and the layers of highway, which can reduce the quality of the highway materials. So that is why also this bitumen material is extensively used in the top layers of the highway pavement, and it is comparatively lower in cost compared to its competitive materials. So bituminous binders are available in various grades with a wide variety of consistency, varying from liquid to semi-solid or to brittle state at varying temperature. So there are various grades of bitumen with wide range of consistency. From consistency here we mean the hardness or softness. So state of bitumen varies from liquid to solid state at different temperatures. So in general, good bitumen should have these following properties. First one is temperature susceptibility. What is the meaning of temperature susceptibility? So the word susceptible means likely to be influenced or affected by. So temperature susceptible material means the material which is likely to be influenced or affected by temperature. So bitumen is a material which is affected by changing temperature. So bitumen changes its shape, its form in different temperatures. So the higher temperature susceptibility means as the temperature changes, the characteristics of bitumens vary at a high rate. And lower temperature susceptibility means with the change of temperature, the characteristics of bitumen are changing slowly. So bitumen needed to be low temperature susceptible. So first quality of bitumen which should be there, that is bituminous material must be flexible enough at low temperature to arrest pavement cracking and to be stiff enough at high temperature to prevent wetting. So here we can understand it in this way that as the temperature is low, the bitumen is in solid state, and as we keep increasing the temperature of the bitumen, it started changing its state from solid to semi-solid, then a viscous liquid, then less viscous liquid. So this is how the consistency of the bitumen, the state of bitumen kept changing with temperature. So at low temperatures, for example, in colder regions, it should be flexible enough. That means it should not be completely brittle. Because in brittle material, as the brittle loads come on the brittle material, the cracks would be generated. So at low temperature, it should be flexible enough, and at high temperature, it should be stiff enough. So for this, various tests on bitumens needed to be done to prevent stiff enough at high temperature to prevent rutting. Rutting is basically the depression in the highways which you have seen under high load. For example, if you are moving in highway and there are different lanes, so the lane which is mostly traveled by the heavyweight commercial vehicles like trucks and other heavyweight vehicles, there you can see depression on the highway under the path of the tires. So this is that depression is known as rutting. So it happens basically in high temperature areas like the areas where temperature reaches above 40 to 50 degrees. So at that high temperature, bitumen started behaving semi-solid form, and under the V loads, it deformed permanently. So these are the properties of bitumen which should be there. So second is the viscosity of bitumen. So viscosity of bitumen is important at the time of mixing and compaction. So at the time of mixing, it should be very less viscous so that it can properly cover the aggregates before laying onto the pavement. Then third property is affinity and adhesion of bitumen. So there should be proper affinity and adhesion of bitumen to aggregates so that they can be used together. So starting from the penetration test. So penetration is a measure of consistency, as I have already talked. So it quantifies the hardness or softness of bitumen by measuring the depth in tenth of a millimeter to which a standard load needle will penetrate vertically in 5 seconds under a specified test temperature, load, and duration of loading. So what are the important things in penetration test? That there is a standard load needle. A needle is used with standard load under a specified temperature. The load of the needle will also be standard, and duration of loading, that is 5 seconds, will also be standard. So 5 second में this the standard loaded needle, how much the standard loaded needle will penetrate into a bitumen at a particular temperature. So that will give the penetration value. As we know, the penetration stands for something which goes into another material. So that will be the penetration. So here in penetration test for bitumen, we use a standard loaded needle with standard dimensions, and that is released under standard load for 5 seconds. And in this 5 seconds, how much it will penetrate into the bitumen material will give the penetration value of bitumen. So penetration value is the depth in tenth of a millimeter. Suppose it penetrates to 5 mm, then its penetration value will be 50. So BIS, that is Bureau of Indian Standards, has standardized the equipment and test procedure. So the penetrometer basically consists of a needle assembly with weight 100 gram. The weight is 100 gram, and a device for releasing and locking it in any position. So there is a device called penetrometer which can release the needle and lock it in any position. So bitumen is softened to a pouring consistency. What does it mean here? Pouring consistency. The consistency, that means the bitumen should be soft enough so that it can be poured from one container to another container. So generally, this temperature for bitumen is above 90 degree or 90 degree. So when bitumen is heated till 90 degree, it comes into such a state, such liquid state, so that it can be poured from one container to the other container. So the depth of the container which is used to pour the bitumen should be at least 15 mm in excess of the expected penetration. So this test should be conducted at a specified temperature of 25 degrees. Third most important thing after load and time of loading is the specified temperature. So this penetration test is basically carried out at 25 degree centigrade, which is again specified by Indian standards. So it may be noted here that penetration value is largely influenced by any of the test parameters which are used. For example, pouring temperature, the size of the needle, the weight which is placed in the needle, and the test temperature. So penetration value will be changed if uh, any of these will change. That is, if pouring temperature can change, the penetration value can differ. So a grade of 40 by 50 bitumen represents the penetration value. It's in range of 40 to 50. So there are various grades of bitumen which are used in construction in our country. For example, a 40-50 grade of bitumen is mentioned. That means its penetration value is in the range of 40 to 50. If there is 100, 80, 100 grade of bitumen, it represents that the penetration value is in the range of 80 to 100. So higher the penetration value, softer is the consistency of bitumen. The higher the needle will penetrate into the bitumen, the softer is the bitumen. So this is one of the most widely used tests for classifying bitumens. Earlier, all the grading of the bitumens, the grades of the bitumens, which are finalized to be used in highway construction, are done only on the basis of penetration test. But in current scenario, various other tests have also been came into existence, which are used to grade the bitumen. For example, viscosity is one of those tests. But earlier, only penetration test was used for grading the bitumen. So moving on to the next slide. So here in this figure, we can say we can have a look to how the penetration test looks like. So first, when the penetration test starts, the needle just touches the bitumen surface. This black liquid is bitumen. So it penetrates into when the needle is released under certain standard load, this needle will penetrate into the bitumen. And the amount by which it is penetrated into the bitumen will give the penetration value. So suppose the amount is 4 mm for which it is penetrated, then the penetration value is 40. So the use of different grade of bitumen depend upon the different climatic conditions and type of construction. So commonly used grades are 30, 40, 60, 70, 80, 100. So generally in warmer regions, lower penetration grade bitumen are preferred, and in colder regions, higher penetration grades like 180 to 200 are used to prevent the occurrence of excessive cracking. The warmer regions with lower penetration grade is preferred because bitumen needed to be hard enough so that at high temperatures also it will not deform under the loads. And in colder regions, the penetration value should be more because bitumen needed to be flexible enough so that it will not generate cracks by bitumen breaking. So this is how the penetration test apparatus looks. This is the cup in which bitumen is poured. This is the needle, and this is the arrangement for releasing the needle. And this is the dial gauge to measure the penetration value. So not wasting much time, this is the standard test of Indian standard, which is used for testing of bitumen and in which penetration test is given. So not wasting much time, we will go to the simulation, how this test will be performed in virtual labs. Okay, so which is the main topic of today's discussion. So when simulation is performed for this test in virtual labs, a window is opened, which will be shown in the next slide. And after that, we will also have a look on how virtual labs works. Okay, so step-wise procedure for carrying out the penetration test in virtual lab is given in incoming slides. So first, this type of page is displayed when we open the penetration test, in which objective of the test is mentioned, then apparatus required will be mentioned, the penetration setup, mold, needle, burner for heating the bitumen, and water bath for maintaining the test temperature. So by clicking on the description, you can get the details of the test. So this is the apparatus which will be shown in virtual test laboratory. Then moving on to the next, we have to click on the bitumen sample to heat it to the pouring consistency using this Bunsen burner, and you have to select the correct answer. So this simulation which is developed in virtual labs, you need to click one by one on all the items which will be used in test, and then the automatically the procedure will be performed. Okay, so first the bitumen needed to be heated when we will perform this test in laboratory. So in that case, first bitumen needed to be heated using Bunsen burner to the pouring consistency. So the pouring temperature needed to be selected, which is 90 degrees. So first we select the pouring temperature and 90 degrees. Then it should be protected from all the dust, and it should be cooled in atmosphere to a temperature of 15 to 30 degrees centigrade for 1 hour. And after that, it will be kept in the water bath to maintain the test temperature. So after this, the bituminous material is poured into the mold, and we need to click on this mold to move it to the water bath. And water bath temperature is maintained at, sorry, here the temperature of water bath is 25 degrees plus minus 1 degree. Okay, so this is how the water bath looks in actual. Here we have controls for maintaining the temperature of the water bath, and water is filled in this chamber, and bitumen is kept in this chamber for 1 hour in order to maintain its temperature to the equivalent to the test temperature. Then after that, the mold is removed from the water bath, and the needle is placed over this mold uh, by just touching this bitumen. So there is a setup in virtual lab in which you can slide this slider up and down in order to move this needle up and down. So it should be adjusted by you so that it just touches the surface of the bitumen. And after that, the reading is set to initial reading is set to 0, and needle is released from this button to make it penetrate into the bitumen under the standard load condition, that is the 100-gram load over this needle. Okay, so then we will get the penetration value in mm. So this test is again repeated for 3 times, and we from that we get the average penetration value, which will be reported as penetration value of 14. So not wasting much time, let us move to the virtual lab platform. Okay, so this is how the home page of the virtual lab looks, and when we proceed towards the civil engineering section and then transportation engineering, we have these different list of experiments. So clicking on the penetration test on bitumen, we have all these listing, that is the aim of the experiment, the theory of the experiment, which we have already discussed. And we have also here in virtual labs some pre-test and post-test, which will include the objective type questions related to this penetration test and related to the physical application of the penetration test. So first, we'll have a look on the simulation, how the penetration test is simulated on this virtual lab platform, and then we will have a look on the pre and post test. Okay, so when the simulation is open, this kind of page is open, in which the objective and apparatus required is mentioned, and the apparatus is set up on the table with the penetrometer, the mold, and the needle. By taking your cursor to description, you can see the description of the test, penetration test, which is most commonly adopted test on bitumen to determine the grade of the material in terms of its hardness because of its simplicity. So again, moving forward, the step 1 would be lighting the burner. So first you need to click on this burner and then cap this bitumen in mold over this burner, and then it is heated to the pouring temperature, and you need to select the pouring temperature from this drop down arrow, which is 90 degrees centigrade, and after clicking OK, you can the bitumen will start heating, and you can switch off this burner from clicking here. Then bitumen will be poured onto the mold which is used for testing. So in this platform, one by one, you need to click on the icons and which will automatically perform the procedure which is done offline when you will perform this test in lab. Okay, so it is very helpful in understanding the whole test procedure by visualizing the test. Okay, so first the bitumen is heated, then it is poured into the mold which is used for this test. Now, some instruction will be given by this page that this sample needed to be protected from dust, and it is needed to be allowed to cool in atmospheric temperature, that is room temperature, for at least 1 hour before putting it into the water bath. So then it is placed to transfer into the water bath. The temperature of the water bath is maintained 25 degrees plus minus 0.1 degrees centigrade unless otherwise stated. So sometimes there is a need to perform the penetration test on some higher or lower temperatures also. So this need actually arises if bitumen is used in construction in some specific areas where temperature is higher or temperature is lower. So that at that time, some temperature specific bitumen penetration test can also be performed. But unless otherwise specified, the standard test temperature is 25 degrees centigrade. Then the bitumen mold is kept into a tray, and then this tray is kept into the water bath. Moving forward, now this sample is placed into the penetrometer apparatus after taking out from the water bath. So by this arrow, every time this simulation lab setup indicates you that what needed to be done next. So now this sample needed to be put it in this penetrometer, and after that this needle is shown here and arrow is shown here. So this needle needed to be put it in the penetrometer, and from this handle, you can adjust the position of the needle so that needle just touches the surface of the bitumen. So here, this part of the penetrometer machine is enlarged here, and from this slider, you can change the position of the needle. आप जैसे जैसे slider down करोगे, the needle will also move down. So needle needed to be adjusted just above the bitumen surface. So a message comes from this side that needle is in position with the sample. So when the needle is in position with the sample, you can proceed forward. And how to calculate the penetration value? One question will be asked here. So penetration value will be final reading minus initial reading. इस dial gauge में जो भी initial reading होगी in millimeters or in penetration value will be subtracted from the final reading, because final reading will be after the penetration has been done, and initial reading would be when the needle is just touching the surface of the bitumen. So you can select the correct answer from the drop down menu, that is final reading minus initial reading, and after giving the correct answer you can now set this dial gauge to 0. So by clicking here, a button is put here over the dial gauge, and by pushing that button the dial gauge is set to the dial gauge is set to 0 again. Now this button, which looks like this a round button, is pressed for 5 seconds, exactly for 5 seconds by looking the time in the stopwatch, and for those 5 seconds the needle is allowed to penetrate in the bitumen. So here you just need to click this button, and for 5 seconds the needle will penetrate automatically, and the dial gauge will give the final reading. This is the 0, and this final reading is between 50 to 100. So here the final reading given is 82. So make at least 3 readings at points on the surface of the sample not less than 10 mm apart and not less than 10 mm from the side of the dish. So on the same mold, 3 readings would be taken, but the readings will be taken on the surface, so that the one reading point will be different, will be at least 10 mm away from the first reading point, and also it should be 10 mm away from the boundary of this bitumen material, that is the boundary of the container, boundary of the mold which is used. So again, the needle is raised, and then the needle is removed from the apparatus, and it is cleaned with benzene, and then again dried, and then again fitted to this apparatus. Okay, this needed to be done each time performing the penetration test for the consecutive 3 readings, because there could be some vitamin which get stick into the needle. So each time the test is repeated. For example, in standard procedure, the test will be repeated for 3 times. So for each time the needle needed to be cleaned with benzene before proceeding further. Okay, so this instruction is also given by the simulation lab. So here it is written that after each test, return the sample and transfer the dish into water bath and wash the needle with benzene and dry it and make the pointer of the dial to reach the zero. So this needed to be done in between each test. So again, the sample is moved to a different value, and then needle will be set again by sliding it above the needle, and then dial gauge reading is set to 0, and again the button will be pushed in order to release the needle for 5 seconds. So it gives the second reading 85. We need to take 3 readings. So we'll take again OK, and we'll again remove the needle and move the sample. Then again set the needle just touching the surface of the button, and after that set the dial gauge to 0. In case in actual offline lab performance, in case you forgot to set the dial gauge on 0 reading, or you don't want to set the dial gauge on 0 reading, so there you can simply note down the initial reading, whatever it is. Then again, this button is pressed to release the needle for the 5 seconds. So the third reading comes out to be 82 centimeters. Is my screen visible and am I audible to all of you?
Yes, ma'am.
Okay. So I'm getting some notifications. That is why. Okay, so we get 3 consecutive reading of penetration, and you need to put the average penetration value by calculating it. That is the average of 82, 85, and 82 again, which comes out to be 83. So after putting this value, you can click this check button and the value is correct. So once again, one question will be asked by the virtual lab, that obtained penetration value is suitable for road construction or not. So you can say it is suitable, and after that, we get this notification that according to IRC, that is Indian Road Congress, between grades of 60, 70 and 80, 100 is suitable for bituminous macadam and penetration macadam. So these are the type of the bituminous construction. Hence, this sample is bitumen suitable for road construction. So what are these types of construction? For example, talking about the penetration macadam. So in penetration macadam, what is done? First, aggregates are laid on the roads, and then they compacted in dry state, and after that bitumen is poured over those aggregates into required consistency, and again the compaction is done. So जितने भी all the voids of the aggregates get filled by the bitumen, and the aggregates are binded together by the bitumen. So this is the penetration macadam type of construction, and then in bituminous macadam type of construction, the aggregates and bitumen are pre-mixed in mixer before placing them onto the highway. So the aggregates and bitumen are pre-mixed at certain temperature and a certain amount of consistency, and then they are placed on the road, and then they are further compacted to get the final load. So according to IRC, जितने भी different types of bituminous construction होते हैं, उनके there are different bitumen grades specified. So for generally for bituminous macadam and penetration macadam, the bitumen grades should be used 60, 70 or 80, 100. One more thing I would like to mention here: if the bituminous construction needed to be done in extreme cold location, for example, in the border roads of Uttarakhand or Himachal or Jammu and Kashmir, where there is extreme negative temperature. So in that case, the penetration value of the bitumen should be high enough because bitumen is needed to be flexible at those temperatures also. So for construction in such extreme situations, there are different standards laid by the IRC. For example, in such extreme negative temperatures, the penetration value should be as high as 180 to 200. Okay, so this completes the simulation of the bitumen, and after apart from this, we have this pre-test also in virtual labs platform, in which you will see different numericals. Like first one, for example, for the first one is to prevent the occurrence of excessive bituminous in colder region. The bituminous grade used would be the only thing which I am discussing right now. So you can select the correct answer from these tests, and after that, okay, sorry. So you can select your correct answer from these tests, and after that you can submit your quiz. So on submitting your quiz, you will get your score below the quiz. So as I have only marked the one answer, my score is 1 out of 5. Okay, so you can do this quiz also in order to access your knowledge regarding the movement test. So for example, you can have a look on these four questions. The last one has shows the bitumen grades 80 to 100 indicates the penetration value of the bitumen is between 80 and 100. Then this test, penetration test on bitumen, is used for determining. So it will determine the grade of the bitumen or viscosity of the bitumen or ductility of the bitumen or temperature susceptibility of the bitumen. So basically it is only required to get the grade of the bitumen, or if there is an option of consistency of bitumen, you could have selected that. So the penetration test is basically done to determine the consistency or grade of the bitumen. Then penetration needle is cleaned with carbon, water, benzene, sodium. So it is cleaned with benzene because bitumen is basically soluble in benzene. So when penetration needle is cleaned with the benzene solution, all the bitumen which is sticking around to the needle could be removed easily. Then what is the test temperature of the bitumen? It is 25 plus minus 0.01 degrees centigrade, which is the standard test temperature unless otherwise specified. Then good bitumen should have temperature susceptibility, adequate viscosity, affinity, and adhesion. So as we have discussed in earlier slides, that all of the three are the requirements of the good bitumen. Okay, so that is it about the penetration test. Now we'll have a small look on the softening point test also quickly. So all these tests are like this only, as we have discussed the penetration test. So coming on to the softening point test. So as the name suggests, it determines the softening point of the bitumen. So softening point is that point at which bitumen attains certain degree of viscosity. So as the name says, bitumen soften to a particular value at the softening point. So softening point test, the softening point is basically a temperature at which bitumen attains a certain value of softness. So softening point of material like bitumen have no definite melting. So bitumen have no definite melting point, but when it is heated, gradually it changes from brittle or solid to a slow flowing material to a more mobile liquid material. As we have already discussed, that as the temperature of the bitumen keep increasing, its consistency differs. So at low temperature it behaves completely like solid, but at higher temperature it can behave like more liquid. So the softening point of bitumen is the temperature at which the substance attains particular degree of softening under specified test conditions. Okay, so the test is conducted using ring and ball apparatus. So we'll see what is ring and ball apparatus, and here the brass ring is used containing the test sample of bitumen is suspended in liquid like water or glycerin at a given temperature. Again, the specified temperature is there in this test also. And a steel ball of certain weight or dimension is placed above the bitumen sample, and the liquid medium is heated at a rate of 5 degrees per minute. So let us have a look on the apparatus. So this is the ring and ball apparatus shown in this figure. Here, this a brass ring is used in which bitumen is filled, and over that a steel ball is kept. And this whole ring and ball apparatus will be kept in a water bath whose temperature is maintained to be 5 degree initially. And after that, this water we start heating of this water in this container, and the temperature of this water rises at a controlled rate of 5 degree per minute. So this is controlled by an apparatus again. So when the temperature is raised at 5 degree per minute, so as the temperature started rising, you can see the mercury level is rising here in this thermometer. This shows the thermometers. So as the temperature started rising, the bitumen will change to solid to more liquid form. So the softening point is the point at which the ball from top of this brass ring falls to the bottom of this ring and ball apparatus. So the distance between these two, upper plate of ring and ball apparatus and lower plate of ring and ball apparatus, is 25 millimeters. Okay. So softening point is the temperature in degree centigrade at which the standard ball passes through the sample of bitumen in mold, falls to a height of 2.5 centimeter or 25 millimeters. So the dimension of the standard ball is 9.5 millimeter, and there is a standard weight also. So the binder material used in pavement construction should have sufficient fluidity before its application. So, softening point will gives the idea about the fluidity of bitumen, that at this temperature bitumen can attain sufficient fluidity so that it can be applied to the road surface. And another importance of softening point test is that if you suppose in any area the bitumen is used for construction and softening point of that bitumen is suppose 50 degrees centigrade, and this bitumen is used in construction in, for example, Rajasthan, where the highest temperature goes as high as 50 degrees centigrade. So when bitumen is already used in road construction, road has been already constructed using that bitumen, but the softening point of that bitumen is 50 degrees centigrade, and highest temperature in that area also goes up to 50 degrees centigrade. So at 50 degrees centigrade, the bitumen will soft and it would be flexible enough so that it can deform permanently under the load. So the softening point also gives an idea about the temperature susceptibility of the bitumen. So the area on which the softening bitumen is used, the softening point should be greater than the highest temperature of the that area, so that when bitumen is utilized in road construction, the softening point of bitumen will never be reached due to the weather condition on that area. So softening point also gives an idea about the temperature susceptibility of the bitumen. Here it is then the higher the softening point, lower is the temperature susceptibility. So we have already talked lower temperature susceptibility means the change in temperature, there is a little change in form of the bitumen. So higher softening point means the temperature at high temperature the bitumen softens, means temperature keep raising from 5 degrees centigrade to 50 degrees centigrade or 60 degrees centigrade, but still bitumen has not changed to a proper softened state, so that the steel ball falls to the lower plate. So higher softening point tells us that bitumen has lower temperature sensitivity, that the change in form of the bitumen is less with change in the temperature. So this type of bitumen is basically preferred in warmer regions because their temperature is the highest temperature of the season goes as high as 40 to 50 degrees centigrade. So the softening point in that areas of bitumen to be used should be more than the highest temperature of the area. So softening point of bitumen for various grade of bitumen used in paving jobs, that is used in pavements, vary between 35 degrees centigrade to 70 degrees centigrade depending upon the area on which the bitumen is used. So this is the relevant Indian standard IS 1205/1978, which is used for determination of softening point. So again, we will have the procedure of the simulation of the softening point test in virtual lab. So skipping this procedure, will directly go to the virtual lab simulation. Again, we will go to the list of the experiments. And here, by clicking on the softening point test, we'll check the softening point test. We have aim, theory, pre-test, procedure, the same contents which are on the penetration test. So we'll directly go to the simulation and we'll look on the procedure. So by clicking on the simulation, we get this, the apparatus for a softening point test, which contains ring and ball apparatus. So this is the ring and ball apparatus. Water bath with stirrer. This is the water bath in which water will be filled. Steel balls and Bunsen burner. So burner will be there. And apart from this, this is the controller machine to control the temperature. So by taking the cursor to the description, we can get the description of the softening point of the bitumen, which is a temperature at which bitumen attains a particular degree of softening under a specific test. So moving further, again, first bitumen needed to be heated to the pouring consistency, that is up to 90 degrees centigrade, the same as it is done in the penetration test. And after this, the burner will be switched off and bitumen is poured into the ring. We have ring and ball apparatus. So these are the rings which is kept above a plate and bitumen with pouring consistency is poured into these rings. So this metal plate which is used down these rings is coated with greaseline and dextrin so that bitumen will not stick onto this plate. So bitumen is poured like this and after cooling in air for 30 minutes, this ring, the excess material over the top of the ring can be removed with the help of a warm sharp knife. So it actually looks like this. I can show you here. Yes. It actually looks like this. This is the brass ring over which the bitumen is poured. So when bitumen is poured, it actually looks like this, and the extra bitumen material over this brass ring can be cut off using a sharp, hot knife. So first the knife is heated, and this extra bitumen over this ring can be showed off. So after the test is performed, it looks something like this. So again, going to the simulation. Okay, so after putting this instruction is given by the virtual lab, clicking on OK and moving to the next. Now, the wings will be put in the bitumen, and after that, the balls will be put above the brass rings which are filled with bitumen. Now, this apparatus, this ring and ball will be kept in the ring and ball apparatus. So number of steel ball used is 2 because there are 2 ring and ball rings. Then moving further, the water is filled into the beaker in which the ring and ball apparatus will be filled. So distilled water is used and the height of the water in this container should be 50 mm above the surface of the rings. So ring का जो surface level होगा उससे water at least it should be 50 mm above these rings. So that a proper and adequate warming of bitumen in the ring and ball apparatus is ensured. So this the level at which there is ring and ball apparatus, the water level should be at least 50 milliliter above that. So after that, this ring and ball apparatus is kept on the heater, and by clicking this, it automatically goes into the heater. Then you need to apply this stirrer in the water so that water keep on stirring so that there is uniform changing of temperature in the water, because when we heat water from the bottom, on the bottom part will be heated first compared to the upper part. So this stirrer needed to be put on the water so that there will be continuous stirring of water to ensure uniform heating of the water. Then this plug is applied for the stirrer and then thermometer will be dipped on this water in order to measure the temperature. Then moving further, initial temperature maintained is 5 degree. The test it starts at 5 degree, and again it is heated at a uniform rate of 5 degree per minute. So temperature is noted when any of the ball touches the bottom plate. So again, we need to switch on the stirrer, then switch on the burner, and then adjust the rate of the temperature, and it will start the stirrer. The temperature from this temperature control, you can see the temperature kept increasing from 5 degrees centigrade, and balls start to fall. The temperature at which the ball touches the bottom is noted. Then the machine will be powered off. So here temperature at which ball 1 drops is 41 degrees centigrade, and temperature at which ball 2 drops is 42 degrees centigrade. Then this is switched off, and we'll move to the next step. So average softening point will be average of these two temperatures, that is 41 degrees centigrade and 42 degrees centigrade, which comes out to 41.5 degrees centigrade, and it is dead. So this will give the softening point of the bitumen. So again, this question is asked here. Bitumen sample with this softening point is suitable to be used in, and there are few options given: Shimla, Rajasthan, Shimla, and Karnataka. So as I have already told you that the softening point should be greater than the highest temperature on any area, so that bitumen is not softened in the highest. So in all these Rajasthan and Karnataka, the highest temperature should be more than 41.5 degrees centigrade. So this softening point bitumen could not be used in Rajasthan and Shimla. So hint also is given here. Choose based on the maximum temperature recorded in the region. So maximum temperature recorded in the region should be less than the softening point. So Shimla would be the answer in which maximum temperature, there is a chances that maximum temperature is less than 41 degrees centigrade. So after that, we get this bitumen with this softening point is suitable for region lesser than this temperature. Okay. The regions where the maximum temperature recorded is less than this temperature. Okay, so it completes the simulation. In softening point test also we have this pre-test objective questions and post-test objective questions. You can go through these objective questions. For example, softening point should be dash the hottest day temperature. So softening point should be higher than the hottest day temperature. The steel ball diameter is asked, which is again 9.5 mm. Then softening point is the temperature at which bitumen disc softens and sag downwards to 25 mm. So we can choose the correct option and submit the test to know the score. Okay, so I guess that's it about the penetration and softening point test. So there are other tests also to know the suitability of the bitumen. For example, viscosity test is there. So viscosity test is generally important to know the viscosity at the time of mixing, because bitumen should be viscous enough at the time of mixing so that it properly coats the aggregates before laying. So for that, viscosity test is there. Then we have ductility test, which tells us about the flexibility of the bitumen. So there are this certain minimum value up to which the thread of the bitumen should be stretched in order to be used in highway construction. So you can go through all other tests through the lab manuals, and you can also directly go through these tests on virtual labs, because we have all these tests. We have ductility also. We don't have viscosity test here, so we have a specific gravity test also here. So specific gravity test is important for mixed design of bitumen, because in bituminous mixed design we need to know the proportion of aggregates and bitumens to be used by volume and weight group. So for that, specific gravity test is important. So yes, you can. I have demonstrated the softening point and penetration test. You can on your own go to the ductility and specific gravity test. So yes, I guess that's it from my side today.
Yes, Dr. Swami, are you done with your presentations?
Yes, sir.
You're done? I guess there's no query because this was illustrated so well. So you have already presented everything before going for the conduction of the laboratory experiment or the virtual lab. So even I was also on the platform, even not aware so much of the experiments about the transportation engineering lab, but I could also learn through your this APT. Dr. Sambi, we are going for conclusion of this session. So I thank you again for illustrating the experiment. So now all the attendees who are present over here throughout the session will definitely have enlightened us from this platform of virtual lab, utilization of experimentation regarding the pavement engineering. And again, I appreciate your efforts because the way you have taken everything,
Thank you, sir.
it was, it was yeah, it was for a native student to from the to the faculty, it was very much clear. So I request you uh, to give us a few words to our attendees before concluding the session.
Okay. Okay. Thank you, Dr. Vinay. Thank you so much for your kind words in appreciation. So yes, this is a great initiative by Ministry of Health and Human Resource, that is MHRD. So every one of us in this pandemic situation, when we cannot access the real labs, we can get benefited from this platform. Apart from transportation engineering, also there are various other lab platforms will be there. So in my opinion, it is in a way to certain students it is more easier to access the virtual labs than it is to access the original lab in the college laboratories. So yes, it is very helpful, and after that when the college reopens for the students, they can have a look on the real machineries and other things in the real lab. So I appreciate this initiative, and all the best from my side to all the students for this semester, so that they can complete the course, all the courses in online mode also in equal quality as it is done in the offline mode. Yes, and all the best to all the teachers also for dealing with tough times, because it is really a burden on the teachers also to be in these situations and make every session informative for the students. So yes, that are the words from my side. Thank you once again, all of you, for joining in. Thank you.
Okay, thank you, Dr. Sambi. We are thank you, Dr. Sambi. If you have any assignment, you please leave because we'll continue for more 5 minutes.
Okay,
Just in order.
okay, sure, sure. Okay, so I will be leaving the session. Thank you once again, everyone, for joining in, and thank you, Dr. Vinay, for inviting me and giving me this
Yeah,
opportunity. Thank you. Thank
it
you.
was pleasure for all of us for having you on the platform. Thank you.
Thank you.